couple of people asked me to review the case of constant pressure versus the case of constant volume. So let's start with the case of constant volume. So at constant volume, as in all cases, delta E is equal to Q plus W. We can use subscripts to indicate that we're working at constant volume. So delta E is equal to Q at constant volume plus work at constant volume. Now, if we're at constant volume, as in our system isn't expanding and it isn't compressing, then there's no work being done. So at constant volume, so work at constant volume is 0. This is if we're considering PV work only. Sometimes there can be other types of work, such as electrical work, but in this course we're only talking about PV work. So if there's no expansion or compression, as in no volume change, work is 0. So delta E then is just equal to QV in the constant volume case. Now let's contrast that with the constant pressure case. So at constant pressure, just like at constant volume, delta E is equal to Q plus W, and we can write that again with the subscripts to show we're in a constant volume path, so QP plus WP. Now remember that at constant pressure, work is equal to negative P opposing times delta V. So delta E is equal to QP minus P delta V. The heat flow at constant pressure is given by delta E plus P delta V. So we can see, as we'd expect, because heat is path dependent, that QV, which is equal to delta E, is different than QP, which is delta E plus P delta V. So we define a new state variable because this QP, this heat flow at constant pressure, is something we're interested in because as chemists we often run reactions at constant pressure. So we want to have some sort of state function that relates to this heat flow at constant pressure. So if we define E plus P delta V as a state function, which we call delta H, enthalpy, then we have a state function that relates directly to QP. So delta H is equal to QP. Formally, enthalpy, H, is defined as E plus PV. So that's the difference between the constant volume case versus the constant pressure case.